Okay, guys, so what we're doing today is page 513, 1 through 12. The good news is this is a pretty short, straightforward little lesson. I probably would have made it longer if you guys were here because there's some graphing involved in the latter part of the lesson. Since you guys don't have graph paper and I don't want to grade your horrible handmade graphs, we're going to skip that part. We have graphed these things before. I think we can get away with that without any major damage. So anyway, we're just going to do 1 through 12. And actually 1 through 8 is really basic, kind of straightforward stuff. So I'll probably just do one of those as an example, unlike normal. So that's kind of what I think of that. And then the last part, 9 through 12, that's kind of new. So I am going to go through those. It's only 4 problems. And really we'll get into that part more tomorrow. So yeah, this kind of bleeds into tomorrow. So I don't know. Do you guys remember what y equals x squared looks like when you graph it? A quadratic function when you graph it. So we've done this before. I don't remember how long ago. Probably 2 or 3 months. Well, quite a while. If you wanted to figure out, you could make like a table, like let x be -2, -1, 0, 1, 2, and like plug x in and see what you get for the y. By the way, I should mention this. These two are the exact same thing, okay? Just a different notation. This is called function notation, okay? When it has the f of x, or it could be a g of x, or whatever. It doesn't really matter what the letters are, but when you use these parentheses things, okay, that just replaces y. We get y by squaring x. This is just a way of saying f depends on what x is, and you have to do x squared to get it. Okay? F of x equals x squared. That's how you would say it. Anyway, do you guys remember what x squared looks like? I'm not going to make a table and plug it in, and we could do that. We've done it before. Hopefully you recall, but it looked something like, something like that. And it was symmetrical, like a mirror image on both sides, and it increased, gets steeper and steeper as it goes up. The shape is called starts with a P, parabola. Good, kids. All right, and anyway, we've done this before, and we've done tricks where, like, if you put a +3 inside the parentheses, it moves it left 3, and then you put a +1, moves up 1. That's stuff we've done before. This is very similar. It's just some more ways that the function, the equation, can be manipulated that we haven't looked at before. Okay, this is the standard. This is the basic. Y equals x squared. Okay, let's look over here. Y equals 2x squared. What do you think is going to happen if I put a 2 in front of the x? Well, without like plugging all the x's in and working it all out, basically what's going to happen is those x values, you're going to square them and double them, so they're going to get bigger even faster. So you could say, probably accurate to say, it's going to go up twice as fast. So if there was a 3 there, guess what? It would go up 3 times as fast. So it would be really steep. Okay, and that's a word that we're going to have to use today. So when you put a 2 in front, or anything bigger than 1, because basically right now the number in front over here is a 1. And we kind of consider this like the normal, that's kind of a starting place. So if you up it, if you turn it into 2, it's just going to get steeper. So it might look like that, something like that. Okay, hopefully see how it's a bit narrower. So over here, like when you plug in x is 2, you should get 4. Over here, when you plug in x is 2, you should get 8. Okay, it just goes up twice as fast. So guess what happens if I put a number less than 1 in front of the x squared? That's right. It's going to go up slower. It's going to be broad, like won't increase at, it'll increase at half the rate that it was on a standard y equals x squared. It'll look broader. The word we're going to use today is flatter. I kind of think of it as broader, but it just won't go up as quick. They're using the word flatter, so we match them. We'll call it flatter. I wouldn't actually count it wrong if you said it's broader. So it would look more like that. So up here, when you plug in x is 2, you'll get y is 4. Up here, or down here, when you plug in x is 2, you'll get y is 2. That's not a very pretty picture, but anyway, doesn't have to be pretty. All right. So when you multiply by a number that's less than 1, it goes slower, so it's going to be flatter, is what we're going to call it. All right. Now, last trick. What if they put a negative in front of the x squared? What do you think will happen? Well, you'll get all the same values, like y values, that you would have got up here, but there'll be negative y values. So what happens is, on the graph, the negative y values are at the bottom. So when you put a negative in front of the x squared, what is going to happen is that it will be upside down. Okay? So it's kind of a mirror image of number 1. It's supposed to look the same, but all the y values that were positive become negative, and what that looks like on the graph is everything goes upside down. Okay? So those are kind of the new tricks. Multiplying by a number in front of the x squared can make it steeper or flatter, and then if you put a negative in front of the x squared, everything's going to drop down. All right. A couple other terms we need to know is normally when there is no negative in front of the x squared, it goes up, and so it has a minimum point. We call that the vertex. We're not from way back when. Okay, that bottom point we call the vertex. Okay, this one still has a vertex. All right, but instead of being a minimum point, it is a maximum point. Like that's the highest that the graph gets. This graph does not have a maximum point. It goes up infinitely. This graph does not have a minimum point. It goes down infinitely. So they're going to ask us, does it have a maximum or a minimum? So if it's a normal positive x squared, it's going to have a minimum because it's going up. So it's got a bottom. If it is a negative in front of your x squared, it's going to be going down, so it has a maximum. All right. So I don't know. On the first section, it's pretty straightforward. The sad thing is, this is one of those questions that is really easy, but if you don't know function notation, you're like, what's going on? Like all these problems, pretty much that we've been doing all year, are something that you would see on the ACT, which is a long ways off, I know, but if you understand function notation, you're going to get an easy question on the ACT. That's what I'm saying here. If you're panicking like that's a long ways off, well, you're going to get a reminder on Algebra 2 plus and then some. Okay, so that's kind of how this works. Okay, I'm not going to do all 1 through 8 odds. Let me try to choose. 8's probably they're not real. They're kind of all the same, but 8's got probably the most going on. So I guess I'll do 8, even though it's an even. All right, I'll do 8. Number 8, f of x equals negative 2x squared plus 8. All right. If you read the directions, it says find for each function. Okay, this is a function. The name of the function is f of x. This is what it does. Okay, that's what that means. That's the same idea as saying y equals negative 2x squared plus 8. And then it says find f of 0, f of 2, f of negative 1, and f of 4. Okay, I read that from the directions. What is f of 0? Okay, all this means is what is the function value going to equal when you use 0 in place of x? And where you use the 0, this doesn't do anything over here. There's no multiplying or anything going on over here. Okay, all the action happens on the right side. The left side is just telling you what to do. This is the name of the function, this is what they want you to do to the function, and this is what the function actually does. Like this is telling you, this is where the magic happens over here. So I'm going to plug in 0 for x squared. Okay, if you use a calculator, can you guys see the negative? Right there. If you use a calculator, I recommend parentheses instead of just putting times. The reason why, big sigh there because this is like probably the 20th time I feel like I've gone over it through the year. If you plug in a negative in your calculator and square it, if you don't use parentheses, it'll spit out a negative. And since we're supposed to square all of x, not just the number in front, but the negative also, okay, you need the negative to be squared. So if there is a negative on the x, you're going to get it wrong unless you put it in parentheses. All right, since this is not negative, we would get it right either way. We could just have put negative 2 times 0 squared plus 8. So if you're using the calculator and you don't remember why or what's going on, just always use parentheses. You should be good. Some calculators might not like you not putting a times between the negative 2 and the parentheses, so you might have to hit negative 2 times parentheses 0 squared. All right, that's what it might look like in your calculator. Really, you don't need a calculator for this. Order of operations, 0 squared is 0. Exponents first. Times negative 2. 0 times negative 2 is 0. Plus 8 is 8. So f of 0 equals 8. That's the first answer. And then, by the way, if we were graphing this, 0 is the x value, 8 is like the f of x value, is like the y value. Okay, so f of x goes in place of y. So if we were graphing it, we'd have to graph a point at 0, 8. Okay, we're not, so you don't have to do that, but anyways. I'm just going to write, I'll just put the answer over here, I guess. We don't really need to write f of 0 equals 8. It's just, we can assume the first question was, what's f of 0? First answer, 8. All right. Second question, what is f of 2? I'm still looking at the directions. There's 4 answers on each of these problems. F of 2 okay, again, the parentheses would not have to be plugged in your calculator because this is a positive 2, so you'll get the same answer either way. So positive 2 squared, that should come first, is 4. 4 times negative 2 is negative 8. Negative 8 plus 8 is 0. So second answer, what is f of 2? F of 2 is 0. All right. F of negative 1. All right, now we got a negative. Okay, so really this is the only number that if you don't plug a parentheses in your calculator with the negative, you're going to get it wrong. All right, negative 1 squared is positive 1. Positive 1 times negative 2 is negative 2, plus 8 is 6. Okay, so you guys get it. We're just plugging stuff in. How many times have we done this year? A bunch. What is F of 4? Last one for this problem. So all eight are like this. So hopefully these will give you some easy answers. If you're not careful on the negatives, they will screw you up. Okay. All right, where are we at? 4. Okay, negative 2 times 4. Okay, 4 squared. 4 times 4 is 16. 16 times negative 2 is negative 32. Plus 8 is negative 24. Okay, those are the 4 answers. Voila. That would be it. Okay, so that's what 1 through 8 looks like. Now 9 through 12 is really the new stuff, and we'll get it. It's only 4 problems, so that's like you do 4, you'll forget it almost immediately. But we're doing it again tomorrow, so you can get a refresher and get it in your brain some more. All right, number 9. Here we go. This goes back to what I was teaching at the beginning of the video. Okay, number 9 says f of x equals 4x squared. I should erase that too. All right, so this goes back to when I had those 4 graphs up here, and what do the numbers in front do? What does the negative in front do to the graph? And that's what they're going to ask us about right now. So I think on this one, just as to help kind of refresh us, I'll make a little pretend graph. What would 4x squared look like? If we can get that in our heads, these answers will pop out pretty easy. All right, 4x squared. If you put a 4 in front of the x squared, it's going to go up 4 times faster. So what it would look like is something really skinny and steep. Okay, that's a key word for us. So on number 9, what direction does it open? Okay, and by open, what direction does it open? Up. The open part is up. Okay, so the first answer on number 9 is up, comma. Okay, the second question is very, very vague. I don't know what they're thinking. It's okay. If you look on 514 on number 9, it says vertex at. Okay, vertex at. So it's asking where's the vertex at? It's kind of weird, but that's what they're asking. The vertex, remember, was that point where it's the bottom or the top, as may be, but it's the bottom of the U. So where's it at? Well, it's just, if you don't do anything to the graph, it's just going to be at 0, 0. That's the location. So the second answer is 0, 0. Okay, it got steeper, but that vertex didn't move. Okay, you guys remember how the vertex moved? Let me remind you. This would move the whole graph 2 to the right. This would move the whole graph up 3. So to the right, up 3. The vertex on this one would be at 2, 3. Like the whole parabola moves up and over. So anyways, hopefully you guys recall that. We're going to need that a little bit on this chapter, those ideas. All right, so this third question, it says, what's the vertex minimum or maximum? Okay, or does the vertex, or sorry, yeah, is the vertex a minimum or a maximum? So this bottom point, is that the minimum of the graph or the maximum of the graph? It's the bottom, so it's the minimum. Minimum. Comma, last question. Compared to the standard y equals x squared, is this graph going to be steeper, flatter, or the same? So the standard y equals x squared looks, like that. Is it going to be steeper, flatter, or stay the same? So if you put a number larger than 1 in front of the x squared, it does get steeper. So basically it's going up 4 times faster than it would on a standard y equals x squared. Okay, number 11. That's it. That was their 4 questions. 1, 2, 3, 4. Okay, number 11 says f of x equals negative x squared plus 4. All right, this plus 4 goes back to what I was talking about from chapters long ago, a couple months ago, whatever. When you put a plus 4 out here, it's not in the parentheses with this x. It's not directly on the x. The plus 4 out here, or if it's a minus 4, it moves the graph up and down. The plus 4 moves the graph up 4. Okay, and that's going to be important. So what did the negative in front of the x squared do? Do you guys remember? This is new to today, so it goes back to my lesson at the beginning. The negative turns all those y values that would be positive become the opposite, so it just turns everything upside down. So if I did a quick sketch of its graph, the plus 4 would move it up 4, but the negative in front of the x squared flips all the y values, so everything that was positive becomes negative. Well, it just turns everything upside down. That's what it does. So plus 4, so let's pretend that was 4 on our graph, so that would be like the vertex. It went up 4, and then the negative turns everything down. All right, so that's a quick sketch of what this graph would look like without me plugging x's in and finding the y values and graphing it like for real. I know it's going to look something like that. All right, so the first question is, what is the direction of its opening? It opens down because the negative makes everything go down. So we're going to put down. Okay, second question, where is the vertex at? Well, because that plus 4 moved everything up 4, the vertex is up. It's not at 0, 0 anymore. It's at 0, because we're not going right or left, 0, 4. Okay, that's where the vertex is at. Is the vertex a maximum or minimum? Okay, it's at the top because the graph's going down. The vertex is at the top, so it is a maximum. Okay, last question. Is it how does it compare to the normal f of x equals x squared? How does it compare to x squared? Well, it flipped upside down, but it's a negative 1 in front of the x squared. It's not going to be any steeper. It's not going to be any, is that the word? Yeah, that's the word they use. It's not going to be any steeper or flatter than a normal x squared. It's upside down, but it's not going to go down at a faster rate than a normal one would go up. Okay, so because the number in front is just a 1 still, basically, it's not steeper or flatter, so it's they put same. Okay, so that last question they're asking, is it steeper or flatter? Or neither? In this case, it's neither. It's going to be the same as a standard y equals x squared function graph. All right, that's it. So that will be all for this lesson. Good luck.